Welcome to the 2.1 homework set problem solving video. So what I'm going to do is take the homework by section and do a sample problem to help you out. So first, as a sample, for number 3, the problems in that section, you're taking a polynomial equation, determining if it is a polynomial equation, and then deciding what the degree is. So for example, I have 2x to the 5th minus 1/2 x plus 9. So the lead coefficient is a 5th power. So with the fact I'm taking x to the 5th, I have x to the 1st, and I have a constant, it is a polynomial equation, referred to the notes from the PowerPoint. The degree is 5, the largest coefficient. The next problem is taking two input-output values and trying to create a linear function. So what we're doing is we're just going to find the slope, use point-slope form to get to a final function. The old practice where we were given an ordered pair set. So what I'm going to do is find the slope, change in y, over change in x. My change in y is going to be 4 minus a negative 1 divided by, so 4 minus a negative 1, then go 2 minus a negative 5. So I'm going to have 4 minus, so 4 plus 1 becomes 5. And I have 2 minus, so I have 2 plus 5, so I have 5 over 7. So there's the slope. I'm going to pick either point. So I'm going to try and set up point-slope form. So this is my y, this is my y1. I'm going to choose this set of points. So I'm going to plug in my y, so y plus 1 because of the negative. Then I have equals m, which is 5 over 7, times x minus negative 5, so x plus 5. So now I just need to solve. Move the 1 over to the other side. So I have 5 over 7 times x plus 5 equals, or minus 1. So now distribute this through. I have 5 over 7x. Multiply that through. I get plus 25 over 7 minus 1. I need to combine this part of the function. So 5 over 7x. So 25 over 7, to get this common, I'm going to make this 7 over 7. So I have 25 minus 7, which gets me 18 over 7. So now I'm going to have plus 18 over 7. Therefore, the function f of x is going to be equal to 5 over 7x plus 18 over 7. So my practice is just finding slope and defining this as point-slope form to find out the slope-intercept form equation, as I have set there. Next set of problems causes us to match a graph with a given function. So what I'm going to do is just show you what the graph looks like, and from that graph you would compare it to the 4 possibilities. So I have function f of x is equal to 2 times x plus 1 squared minus 3. Now this is a vertex form. Vertex form is a times x minus h squared plus k. This signifies shifts left and right. This signifies shifts up and down. This value signifies my stretch or compression. So looking at my graph, I have the original y equals x squared here, and I've taken that and I've shifted it 1 unit to the left for the x plus 1 and 3 units down for the negative 3. But then what I've also done is I've stretched this with the multiplication of 2. So I'm looking for a parabolic function that has been shifted to the left 1 unit, down 2 units, and then vertically stretched by 2. So I find that function in my options, or I find that graph in my options, and that is my result. So for the next case, I'm trying to determine my transformation of y equals f of x. So I have h of x. So h of x is going to be some type of transformation of f of x equals x squared. So identifying pieces, I have 1/4 times x squared, and then I have -1. So what I've actually done is I've taken x over 2 squared minus 1. So I've dropped the original function 1 unit down, and then I have also taken, I've taken this 1/4, multiplied it into the x squared. So what I've actually done is taken a factor c equal to 2, multiplied that in with the x over c, so I have a horizontal stretch. By 2. So looking at my function, horizontal stretch by 2, I've horizontally stretched this out by 2. So next problem, I'm determining a vertex and the axis. This axis is the axis of symmetry. So standard form for vertex, or vertex form, is a times x plus 2 squared minus 1. So excuse me, let's do this. So I have g of x is equal to -3 times x plus 2 squared minus 1. The actual form that I'm looking for vertex form is ax minus h squared plus k. So a is determining my stretching and compression. H is determining a shift left or right. K is determining a shift up and down. So all I have to do is determine for vertex is find HK. So in this case I have plus 2 minus 1. Well, the actual value there would actually be a -2. That would turn this positive. So I have -2 initially as the x coordinate of my vertex. And then I have dropped down by 1. That as is my vertex. So I have -2 and 1 for my vertex. Now the axis, or axis of symmetry, is just an equation x equal to whatever that h value is. So I have x equals -2. That's the axis of symmetry in which I could fold the parabola upon itself, and I have 2 overlapping parts. So for the next case, I'm using 28. F of x equals -2x squared plus 7x minus 3 to identify vertex and axis of symmetry. So what I'm going to do is put this into vertex form. So I'm going to have to turn this into f of x equals 8, or a times x minus h squared plus k. So the first thing I'm going to do is identify if the lead factor multiplied into the x squared is 1. If it's not, I got to pull that out of the entire equation. So I'm going to pull a -2 from everything. So that makes now that lead just x squared, but it turns this into a -7 over 2x. If I multiply that -2 in, I get the 7x again. I now also have plus 3 over 2, because if I multiply that into the equation, I'd go back to my original. So I've pulled that -2 out. That represents my reflection and also represents my stretch/compression. So now what I'm going to do is I'm going to work to complete the square here. So I'm going to write a large bracket in order to keep things organized. So I'm going to take x squared minus 7 over 2x. I'm going to leave some space because I'm going to try and put a constant here that will turn this entire piece into a perfect square. I still have plus 3 over 2. And when I put that constant in, so I'm going to add it here, I'm going to subtract it here, so that, again, I'm keeping a balanced equation. So, real quick, just as in completing the square for a value, I need to figure out what if I take negative 7 over 2 divided by 2, what that result is. So when I take 7 over 2, negative 7 over 2 divided by 2, I end up with negative 7 over 4. So I'm going to take that negative 7 over 4 and I'm going to square it. That's going to be the value I plug in here. So that becomes 49 over 16. So I'm going to take 49 over 16, 49 over 16, and I'm going to be adding it and subtracting it, because if I cancel these out, I can go back to my original equation. So now, as I have this set up, I now have a perfect square. I'm going to have negative 2 times, and I'm going to keep my brackets just to keep things kind of cleaned up right now. I'm going to have negative 2 times x. This becomes a nice perfect square using this value, x minus 7 over 4 squared. And then I also now have this positive 3/2 minus 49 over 16. My result with 3/2 minus 49 over 16 is going to be negative 25 all over a 16. Now I'm going to distribute this negative 2 into the equation. But in this case here, I'm only going to rewrite the binomial as is. Reason being, I cannot distribute that into these parts, but I have distributed it into the actual equation. I'm also going to distribute the negative 2 into the negative 25 over 16. That gets me positive 25 all over 8. So from this, I could actually identify a vertex. I have vertex, I have my h, and I have my k. My h is 7/4, my k is 25 over 8. Then I have my axis of symmetry is x equal to my h value, which is just 7 over 4. And to double check, I could take a look at y equals. I've put in both equations, the one that was the original, the one that I came up with, and I trace and they overlap. I created the same equation, but now I turned it into vertex form. So my format of vertex form is as such, and I've also identified the vertex and the axis. So now I'm going to complete the square and describe what's happening with this function. So I'm going to do a similar practice to the problem I did prior, but the nice thing about this is I don't have a value I need to pull out. So I have g of x is equal to, now I'm going to have x squared minus 6x. I'm going to create the perfect square there. I'm going to add 12. I'm going to add that value there, but then I'm going to subtract it here to keep things balanced. So looking at this, if I take 6 divided by 2, I got a nice value. I get 3. 6 over 2 equals 3, but keep in mind that was minus 6, a negative 6. Now if I take and I square that value, I get positive 9. So I'm going to be adding that positive 9, subtracting that positive 9. When I do that, this now becomes a nice perfect square using this value. G of x equals x minus 3 squared, and then I have plus 12 minus 9. I'm going to have plus 3. So describing, this is a shift and adjustment of x squared. I haven't stretched or compressed because this value is 1 that's being multiplied in. So I have a vertex of 3, 3, an axis of symmetry of x equals 3 from the 3 here. So what this is f of x equals x squared shifted 3 units right and up 3 units. All from defining and finding the vertex form and taking and describing that vertex form. Next set of problems gives me the vertex point and then gives me another point on that graph, and I need to find the equation from that. So all I'm doing is taking f of x equal to a times x minus h squared plus k. Well, defining the point they gave me as the vertex, that is my hk, 1 and 5. It is actually negative 1 and positive 5. So from that negative 1, 5, I can rewrite that f of x to be equal to a times x plus h, which is the plus because that becomes negative, negative, positive, squared, plus 5. But the problem is that I am missing a. That's why this other point is given. What I'm going to do with that point is I'm going to take and plug that in to find out a. So taking and plugging in, I'm going to have negative 13 equals f when I plug in 2, which is equal to a times x, which is 2, plus 1 squared plus 5. And I'm just going to solve, so I have negative 13 equals, and this becomes 3 squared, so a times 3 squared plus 5. I'm going to subtract 5 to negative 18. And this equals 9 times a by 9 by 9. I get a equals negative 2. So from that value, I go plug in, and I end up having my actual function, f of x equals negative 2 times x plus 1 squared plus 5. That is the vertex form of the equation. The process was to take the vertex point to set up the vertex form, and once I have that vertex form set up, the other point allows me to figure out what a is, which I've done down here at the bottom. The last problem I'm going to do is number 44, which is the same practice that I just previously did. So again, I have f of x, vertex form is a times x minus h squared plus k. So I'm going to take this point, plug it in. So I have f of x equals a times x plus 2 squared because of the minus 2. And then I have the negative 5, so minus 5. So now all I'm going to do is find a. In order to do that, I'm plugging in f of x, which is negative 4, which I'm going to plug in, equals a times negative 4 plus 2 squared minus 5. That all equals negative 27. So now solving out, this is negative 4 plus 2, so I have negative 2, I'm going to square, minus 5 equals negative 27. This becomes just positive 4a minus 5 equals negative 27. Add 5, add 5. I have 4a equals negative 27 plus 5. So I have negative 22. It's not a great value that I end up with, but I just have to reduce down. Move the paper up. So now, looking at that, this is negative 22 over 4. I'm going to have negative 11 over 2. It's ugly, but that is the a value that I'm going to plug in up top. My actual function f of x is equal to negative 11 over 2 times x plus 2 squared minus 5. I hope this information helped. Please be sure to backtrack through the YouTube video and the PowerPoint in order to get help. Take your time with the problems, and keep in mind that we will be going over these problems this week further. but please get started on them. Good luck. Have a good day.